Hi everybody, and welcome back for your task 4.11 video. This video is going to be primarily about justifying our reasoning. Now, our learning target for today is going to be I can justify my reasoning about inequalities. We've been doing some justification throughout this unit, but this video is really going to focus on how to explain your thinking and go through a lot of example problems where we're justifying our answers about inequalities. Earlier in this unit, we talked about that when you're graphing or writing an inequality, there are three features you need to consider. You need to consider the starting value. So, what was the important number that was used in the inequality, and was that used properly on the graph or in the interval notation? You need to consider whether an open or a closed circle is used. As a reminder, we use an open circle whenever there is a less than or a greater than, and we use a closed circle when there's a less than or equal to or a greater than or equal to. And you need to consider the direction of shading. So as a reminder, we're going to shade to the right, which means towards positive infinity. When we have a greater than or equal to, and we're going to shade to the left, which means we're shading towards negative infinity whenever we have a less than or equal to. Okay. Joaquin and Serena work together productively in their math class. They both contribute to their thinking, and when they disagree, they both give their reasons, then decide together who is right. In problem number 1, it says Joaquin and Serena are assigned to graph the inequality x is less than -7. Now, Joaquin thinks that the graph should have an open dot on the -7, and Serena thinks that the graph should have a closed dot on the -7. Explain who is correct and why. Now, the big difference here is that Joaquin thinks that there should be an open circle, and Serena thinks that there should be a closed circle. The way we decide that is we look at the inequality. Since there is no equal to, there's no little underline underneath the less than, that tells us we should use an open circle. So if we wanted to explain who is correct, we would say Joaquin is correct. And we would say that since the inequality is a less than, we should use an open circle. So since it's a less than, we should use an open circle. There is no equal to. Next, it says Joaquin and Serena are asked to graph the inequality x is greater than or equal to -2. Their solutions are shown below. Explain who is correct and why. The first thing we should check is, did they graph this on the correct number? That's the starting value. My starting value is -2, and both of these graphs start on the -2, so that's good. The second thing that we should check is, did they use an open or a closed circle correctly? In this case, because there's a little underline, there should be a closed circle. Since this graph has a closed circle, that's making me think that that graph is correct because it shouldn't be an open circle. And then the last thing is that because we have a greater than here, we should be shading to the right, and both graphs are shaded to the right. So that's good. That means the only graph that meets all three criteria for being correct is Serena's graph. So we would say Serena is correct. Now, in order to be correct, Serena had to do three things correctly. So we need to sort of list those things here. First, the graph started on the -2. Then she correctly used a closed circle. So I need to say that she used a closed circle because of the equal to. the underline. And last, she shaded in the correct direction. So shaded to the right because it was a greater than, whereas she would have shaded left if it was a less than. Okay, next. It says Serena solved an inequality and determined that the solution set is x is greater than -8. She expressed her answer as -infinity, comma, -8. Would this be appropriate interval notation? So what this is basically asking us is, does x is greater than -8 mean the same thing as -infinity, comma, -8? A great strategy here for doing this is to visualize this on a number line. So real quick, right up here, I'm going to sketch x is greater than -8 on my number line. X is greater than -8 means I'm going to put an open circle on the -8 and I'm going to shade to the right. Now that tells me that my interval should go from -8 to infinity, not towards -infinity. So that makes me think that Serena is incorrect. So I would say Serena is incorrect. Why is this incorrect? Because she started on the -8, that was great, but it should go towards positive infinity, not negative infinity, since we are looking for the numbers that are greater. So we would just say that. We would say the interval should have been -8 comma infinity because the inequality is a greater than. So we look at the numbers that are bigger than -8, not the numbers that are smaller, which is what she originally wrote. For number 4, it says Serena solved an inequality and determined that the solution set is x is less than or equal to 10. She expressed her answer as -infinity, comma 10 with a parentheses. Would this be appropriate and why? In this case, again, I'm going to sketch a little picture. I find that that helps me to visualize my solution, and then that helps me to connect my interval and my inequality notation. Now, my important number here would be 10, and I would use a closed circle and shade to the left. Now that means if I was going to write my interval notation, I would have used a bracket here because it's a closed circle. But I still would have used -infinity, so that part was correct. That means that Serena is incorrect. So I would say Serena is incorrect. And the reason is because the interval should have been -infinity, comma 10 with a bracket because the inequality has an equal to. So the endpoint is closed. So it's included, it's closed, so we needed to use a bracket. Next, it says for number 5, Serena wonders about the equation -x/3 is equal to 4, and the inequality -x/3 is greater than 4. Explain to Serena ways that solving these two problems are alike and ways that they are different. How are the solutions to the problems alike and different? Well, in this case, when I'm solving, the only thing that's different is that when I solve, because there's a negative here, I'm going to end up flipping the inequality. So the first thing that I would say is, how are these solving these two problems alike and how are they different? I would say solving these two problems is exactly the same, except when you divide or multiply by a negative, number, you would need to flip the inequality. Now, the second part of this question is, how are the solutions to the problems alike and different? And the difference is that when you solve an equation, there's one solution, and when you solve an inequality, there are lots and lots of solutions. And so it's just a group of numbers versus one number when you have an equation. So I would say the solution to an equation is one number, whereas an inequality has many solutions. It's a group of numbers. Now, in my last problem here, it says Serena is checking her work with Joaquin and finds that they disagree on a problem. Here's what Serena wrote. Is she right? And explain why or why not. Now, what I like to do is kind of do the problem myself and see where our work might be the same or might be different. So if I was to do this problem, I would start by subtracting 3 on both sides. And when I do that, the 3's cancel, and so I just get 3x is less than or equal to negative 2x, and 5 minus 3 is 2. That step checks out. Then I would add 2x on both sides to undo the minus. Uh-oh, it looks like she subtracted 2x on both sides, but the opposite of subtraction is actually addition. So she should have added to the 2x on both sides. That is why she is incorrect. So here's what I would say. I would say Serena is incorrect. And I would say because she should have added 2x on both sides because adding is the inverse of subtraction. So she should have actually added in that step instead of subtracting, and that's why her answer is incorrect. Okay, now the last thing that I'm going to do is say thank you guys so much for watching and have a wonderful afternoon, and I will see you soon for some practice with justifying your answers.